For decades, naval warfare has relied on sophisticated missile defense systems and conventional artillery. However, as independent defense analysts suggest, these established methods are increasingly falling behind the curve. The rise of next-generation threats, notably hypersonic missiles and advanced anti-ship weapons, has exposed critical vulnerabilities. These new threats operate at speeds and with maneuverability that traditional interception systems, designed for a different era, simply cannot counteract. The question now isn't if a new solution is needed, but rather, what form that solution takes. The core problem, according to military strategists, is speed. Conventional naval artillery, while powerful, launches projectiles at speeds insufficient to reliably intercept objects moving at Mach 5 or higher. Missile defense systems face similar limitations, relying on complex interceptors that require precious seconds to lock on and engage. In an environment where every millisecond counts, the speed gap between offense and defense has become a chasm. This has spurred a radical re-evaluation of naval weapon platforms, pushing designers towards entirely new paradigms of firepower. This is where the electromagnetic railgun, or EMRG, enters the strategic picture. For years, it was a futuristic concept, often relegated to science fiction. However, recent developments, including a confirmed classified operational deployment by the U.S. Navy, indicate it is now a very real, and deployed, weapons system. The EMRG fundamentally redefines projectile velocity, moving beyond the chemical propellants of traditional guns. This shift promises to offer a solution to the speed imperative that has plagued modern naval defense. The operational principle behind the EMRG is remarkably elegant in its brutality. Unlike a conventional gun that uses an explosive charge to generate gas pressure, an EMRG employs pure electrical energy. As described by leading physicists, powerful currents are passed through two parallel rails. When a conductive projectile, or armature, is placed between these rails, the interaction of the currents creates an immense electromagnetic force, known as the Lorentz force, accelerating the projectile to extraordinary velocities. This isn't an explosion, it's a precisely controlled, colossal surge of energy. The result of this electromagnetic acceleration is velocity unprecedented in naval artillery. Official reports, though sparse due to classification, suggest railgun projectiles exit the barrel at speeds exceeding Mach 6, with some speculation placing them closer to Mach 7 or even higher. At these velocities, a solid, non-explosive projectile transforms into a devastating kinetic weapon. The sheer impact energy alone, without any explosive warhead, is sufficient to neutralize hardened targets, piercing armor and structures through kinetic force. This is a game-changer for engagement profiles. While specific range figures for the newly deployed railguns remain classified, informed speculation, based on historical EMRG test data, suggests they significantly exceed conventional naval guns. Reports indicate potential ranges from 100 nautical miles, 185 kilometers, up to 200 nautical miles, 370 kilometers, or even more. This extended reach allows naval assets to engage threats from a much safer standoff distance, reducing vulnerability and expanding their operational area. The ability to strike further, faster, dramatically alters tactical engagements. The U.S. Navy's stealth destroyers mentioned in the context of railgun deployment almost certainly refer to the Zumwalt class. These ships, originally designed for land attack and stealth operations, possess a unique characteristic that makes them ideal: an integrated power system, or IPS. Unlike other naval vessels, the Zumwalt class was engineered from the keel up to generate immense amounts of electrical power, far beyond what's typically required for propulsion and standard systems. This excess capacity is crucial for the energy-intensive railgun technology. The electrical demands of firing an EMRG are staggering. A single shot requires a massive, instantaneous surge of energy, far exceeding the output of typical ship generators. The Zumwalt-class destroyer's integrated power system addresses this head-on, capable of generating an astounding 78 megawatts (MW) of power. This capacity isn't just for propulsion, it's a dedicated energy reservoir perfectly suited to charge and fire an electromagnetic railgun, distinguishing the Zumwalt from nearly every other warship in the fleet. This power output is critical for sustained operation. Beyond its destructive capability, the railgun offers a profound economic advantage. According to various defense analyses, a single railgun projectile costs approximately $25,000. Compare this to modern guided missiles, which can range from $1 million to $2 million per unit. This orders of magnitude difference in cost means a naval vessel can carry and deploy significantly more firepower for the same budget. This isn't just about saving money, it's about altering the cost-exchange ratio of naval combat fundamentally, allowing for greater sustained engagement. The lower cost of railgun projectiles also correlates with an increased magazine capacity. Unlike missile launchers, which are limited by the physical cells of a vertical launching system, railgun projectiles are relatively compact. This allows stealth destroyers to theoretically carry hundreds, perhaps even thousands, of these projectiles. This immense magazine depth provides an unprecedented capacity for sustained fire and long-duration engagements, without the constant need for resupply, offering a distinct tactical advantage over adversaries reliant on fewer, more expensive munitions. The most significant strategic impact of the railgun lies in its ability to invalidate enemy missile defense networks. As defense analysts have detailed, traditional anti-missile systems are designed to intercept threats moving at specific velocities and trajectories. However, a projectile traveling at Mach 7, faster than most current interceptors and with potentially non-ballistic trajectories, presents an entirely new challenge. The sheer speed drastically reduces reaction time, making lock-on and interception practically impossible for existing systems. To illustrate the challenge, consider this: traditional missile defense systems require several seconds for detection, tracking, target classification, launch authorization, and interceptor flight. Even with advanced sensors, a Mach 7 projectile covers ground so rapidly that these sequential steps simply cannot be completed in time. A projectile launched 100 miles away could hit its target in under a minute, leaving precious little time for any defense. This speed dramatically compresses the decision-making cycle for any adversary, creating an insurmountable dilemma. Let's compare the engagement profile of a railgun with a conventional naval gun, like the 5-inch/62 cal Mark 45, which is a backbone of many fleets. The Mark 45 fires projectiles at roughly Mach 2.5 to 3.0 with a range of around 13 to 20 nautical miles for precision munitions. The railgun, in stark contrast, operates at Mach 7+, with ranges potentially 10 times greater. This disparity means the railgun can engage and neutralize threats long before they enter the engagement envelope of traditional artillery, a critical tactical advantage in peer-to-peer conflict. The railgun's hypervelocity projectiles pose a unique challenge even to advanced missile defense systems, often optimized for ballistic missile trajectories. Railgun projectiles are not only faster, but can potentially be maneuvered in ways that make traditional ballistic intercepts ineffective. They do not emit a large heat signature like a rocket engine, making them harder to track via infrared. This combination of speed, potential maneuverability, and stealthy profile creates a kill chain nightmare for any defensive array. The very essence of interception logic is undermined. Publicly, the EMRG program faced significant development hurdles, including managing extreme heat, mitigating barrel erosion from hypervelocity shots, and refining power storage for sustained firing. However, the classified operational deployment suggests these critical challenges have been addressed. This implies breakthroughs in materials science, advanced cooling systems, and sophisticated power conditioning technologies have moved the EMRG from the testing range to active duty, marking a crucial, though unannounced, triumph in defense engineering. The sudden confirmation of a classified operational deployment is telling, especially given the public discourse around 2018 to 2019 suggested a de-emphasis on the EMRG in favor of hypervelocity projectiles for conventional guns. This discrepancy, as noted by defense journalists, suggests a deliberate strategy of compartmentalization. While public funding may have shifted, covert development clearly continued, culminating in this unannounced operational status. The silence from official channels underscores the strategic sensitivity of this technological leap. The operational deployment of the electromagnetic railgun fundamentally transforms naval doctrine. It shifts the tactical advantage decisively towards the offense, providing a critical edge against peer adversaries. Ships equipped with these systems can project power with unprecedented speed and precision, at significantly lower cost per engagement. This change forces other navies to reconsider their defensive capabilities and invest heavily in countermeasures, potentially sparking a new, high-stakes arms race in naval technology. It's a paradigm shift in how sea power is projected and defended. The integration of hypersonic railguns aboard stealth destroyers marks a new chapter in naval combat, one where speed and kinetic energy reign supreme. This isn't merely an upgrade, it's a redefinition of what naval artillery can achieve and what defenses are required to counter it. As these systems become more prevalent, the landscape of maritime power projection will irrevocably change. The era of traditional artillery being the primary ship-to-ship weapon may be ending, giving way to an age of lightning-fast, hyper-accurate, and economically viable kinetic deterrence.